Hello, everyone, and welcome to the Unified Leadership Institute. I'm Christopher Hornick, President and CEO of HBSC Strategic Services. We are an enterprise digital and organizational transformation company. I'm also a fellow at the Unified Leadership Institute and author of The Last Book of Leadership. Dear listeners, prepare to be transported into the dynamic universe where cutting-edge artificial intelligence meets true business value. Today on the Unified Leadership Podcast, we have the honor of introducing you to a luminary in the realm of AI, a true maestro who orchestrates symphonies of data, a leader who seamlessly fuses the art of traditional predictive analytics and the astounding emergent properties of generative AI. Dr. Eric Siegel is a trailblazer who's been navigating the uncharted waters of AI long before it became a buzzword. He is an expert in predictive analytics, and his contributions are redefining business value delivery through the enterprise. Among his many accomplishments include, he's the founder of Predictive Analytics World. He's a former Columbia University professor of computer science. He's a two-time published author, Predictive Analytics and the AI Playbook. And he also has published multiple articles, including various journals, such as the Harvard Business Review, Forbes, and the Wall Street Journal. He also has multiple courses on Coursera. And my favorite, he is the creator and producer of the Dr. Data rap music video, the first rap music video on the topic of big data. Really good. Don't miss it. If you haven't seen it, definitely check that out. But beyond his staggering achievements lies a person passionately dedicated to advancing our understanding of what AI can do for business and human progress. Imagine a man whose expertise has the power to unravel the secrets of data, to breathe life into algorithms, and to transform the mundane into pure insight. Eric's story is one of relentless curiosity, of pushing boundaries, and unveiling the hidden potential of artificial intelligence. So fasten your seatbelts and get ready for a whirlwind journey through the future of AI as we delve deep into this fascinating topic. On this podcast, Eric Siegel will challenge your perception of what's possible at the dynamic intersection of business and artificial intelligence. Eric Siegel, welcome to this episode of the Unified Leadership Podcast.
Thank you, Chris. That was amazing. So, most people write their own bio, but I didn't write this one. That's very generous of you. Luminary, maestro, and trailblazer. I'm definitely going to take those words and put them into my self-autobiographical bio.
Oh, I think that's great. Yeah, feel free to have any type of poetic license there. That's great. So, Eric, it's great to have you here. You and I have had many conversations around predictive analytics and artificial intelligence and generative AI. I think one of the good places to start here, there's a lot of different types of neural networks out there, and I think it's good to actually sort of classify them for folks who are listening here. Can you actually talk to us a little about sort of what the hierarchy or ontology is of deep learning, machine learning, and generative AI, how they actually fit together and how they relate to each other?
Yeah, sure. You got AI. It could mean anything. The word means anything. It's ill-defined. Machine learning definitely within that. Neural networks is a kind of machine learning, and deep learning is a kind of neural networks. So let's just start with machine learning in general, whether it's a neural network and whether you're using it for generative or whatever. The main enterprise use cases that have been established for years now is to use machine learning to predict for each individual. Now, it could be an individual human, like a customer, a healthcare patient. It could be another company for B2B, any kind of customer, whether it's a human or an organization. It could be an individual satellite's going to run out of battery, a building that might be a risk of fire. You're making predictions of the outcome or behavior for each individual in order to target and more effectively run large-scale operations by driving those individual decisions based on the prediction for that individual. Should I target marketing because this person's predicted to buy? Should I approve an insurance application because this person's predicted to be a low risk policyholder? Should I approve this application for credit risk? Again, it's based on predicting an outcome. Should I approve this transaction because it's a low risk of turning out to be fraud? So in the case of fraud, you're not actually literally predicting the future, but you're ascertaining an unknown, a category. And that's really what the definition of this technology is: to learn from data to predict, to automatically develop a predictive model based on historical data because we're learning from history. Data is a recording of the past. It encodes the collective experience of organizations, all the positive and negative cases that have been witnessed in the past, from which it's possible to learn, to automatically develop, generate a model. And the model's job now is to generate these per individual predictions one at a time. And the thing that's, I'll call it magical or extremely scientifically cool about the technology, what's exciting, what got me into it, is the ability for this model to perform well in general. That is to say, be able to handle and predict with the same level of precision and reliability for new situations that have never before been encountered, that were not included within the historical training data, no matter how big it was, because there's sort of an uncannibal, every snowflake is unique, every customer situation is unique, every transaction and all the ins and outs that describe that transaction is unique. So the ability to learn from examples, to render predictions that are consistent, to perform consistently well in general over new situations, yeah, that means you've actually drawn generalizations from some limited view and set of examples of the past. So that's what's cool. That's what machine learning does. Now, if you take that core technology, so the way that it applies for enterprises in general is all the kind of use cases I just mentioned. That's what's been established, especially in more recent years. You're targeting fraud investigation, marketing, credit scoring, insurance insurance selection, application processing, targeting of which building or manhole cover to inspect for possible fire, which ad to display to this user. And you're targeting all these things based on per individual predictions. So in other words, those are use cases. One way to define them, these kind of enterprise efficiency use cases, is that you're using the output of the model, its predictions, which is usually in the form of a probability, to drive an organizational decision, lots of decisions. Right. Now, the new thing that's happening is generative AI. The core technology is within the same camp. It's machine learning. It's just that it's being used in a very particular way. And basically, in the case of a language model, for example, it's generating language because it's just predicting what should the next word be. That's a slight simplification, but that's on the level of what it does. And by doing that, you just keep predicting the next word so it can write. And if it can write in a way that seems human-like, which is what it was trained to do, maybe it's also useful in other more general ways. That's sort of the speculation. That's the excitement. So when you look at the field of AI, you have to see that there's these two, what are really becoming two very different parts of the field that are really like apples and oranges. They're just two very different ways. And there's a lot of ways to compare them. And there's a lot of shared overhead in the core technology and sort of the science underlying what it means to learn from data. But in general, the enterprise efficiency cases, and that's where you've got the proven value established for years now, that's where you can improve all the largest main operations of organizations. So all the main things we do as people, as organizations, that's where you have the potential to improve it. And in those, the thing that you're predicting is something that generally cannot be predicted as well as a magic crystal ball. You can predict better than guessing. And I call that the prediction effect in I mentioned it in both of my books. But the predicting better than guessing drives value. You can't predict who's going to click on this ad, click, buy, lie, or die in the subtitle of my first book. These kinds of outcomes or behaviors, often human behaviors for many of these business use cases, can only be predicted with so much precision and confidence. No matter how much data you have and how advanced the core technology is, we can't be clairvoyant, and we can't expect computers to be clairvoyant either. So the nature of those established enterprise use cases generally fall into a category where there's sort of an implicit ceiling, and you can inch it up a little bit more, but no matter how great the technology gets, no one's going to be able to predict exactly who's going to buy an ice cream cone next Wednesday. It's just not possible. You just can put odds on it, much better odds than guessing, and thereby target marketing better and target all kinds of operational processes better. Now, think about that in comparison to what's happening with generative AI, large language models. It's going to predict what should the next word be, and it does it so well based on the last, 3 paragraphs or even more of text. The only way it does that, and it's learned to do that from such an extraordinary amount of data, is that on some level, it is huge neural network has the ability to ascertain and encode a quote meaning of the words and of the sentences and of the paragraph in order so that the next series of words continue to seem to make sense to a human reader. Now, the word meaning is very subjective, and the degree to which that's approaching a human level capability is probably not nearly as high as many people perceive it, but it is extremely impressive. So when we kind of look at that advent of generative AI, I actually spent in grad school in a previous life, long time ago, 6 years in the natural language processing research group. And I never thought I'd see the kind of capabilities we see now in my lifetime. Absolutely not. I'm completely astonished about it. I'm extremely amazed. At the same time, I'm like, the rest of the world seems to be 10 times as amazed. I mean, I'm extremely amazed, but the world's actually too amazed.
Yeah, I mean, I think there is sort of an overhyping of what's going on. And I like what you were actually talking about. Sort of everything that we're talking about here is based on probability. And so it's not actually absolute prediction, but it is probability. And that, I mean, and a lot of things are happening with generative AI. I think where people are actually more amazed than sort of the next word that it can actually predict, it's really sort of the emerging properties that are actually, coming about that are surprising. And so like when you see that basically a AI generative application, that can basically pass the bar with 99% accuracy, or can pass the medical exam, like to become a doctor with 98%, accuracy, or basically understand gap accounting better than say 80% of the people who are actually CPAs. That actually is an incredible thing. And so when you talk about that, so that's where I think that people are coming up with these emerging properties, that it's not just predicting the right word, it's actually sort of understanding a little bit more of the context than humans can actually sort of comprehend. And that's why it can pass these tests that are so difficult for humans to do, because it's seen so much more data than typically humans have seen.
But I'd like to qualify that. When we apply tests that are designed to evaluate humans as we understand them, and we use them to test machines, therein lies a kind of fallacy, because seeing the machine do as well as a human makes you think that the machine might be generally capable like a human, and that's absolutely untrue. So here's the huge irony that the world needs to wrap its head around. The advent of generative AI makes the machine so much more seemingly human-like, and yet by virtue of doing that, this technology is actually less potentially autonomous. So unlike the enterprise use cases I was describing, where it can be for many of those fully autonomous, decide on the fly, should this credit card charge be authorized, or should it be held as potentially fraudulent? It's automatically doing that. But when we talk about the kind of thing you might do with a large language model, which seems so human-like, it's always, or almost always, except for very limited areas, at least with the state of the art, not autonomous. It's got to be manually supervised on a per case basis. There's got to be human in the loop, not just in the design, but every time it generates a new draft of something, somebody's got to proofread it.
Right. Yeah. And, and along those lines, I would agree that a lot of the things that will happen around generative do need sort of that supervision in order to actually be viable. The interesting part to me is that going back to our last discussion about sort of the hype cycle around a lot of these technologies. What are sort of your top 3 myths that have emerged, say in the last year or two around generative AI or predictive analytics, about what it can and can't do? To your point, basically, the predictive analytics is very well understood at, say, at the Fortune 500 level about what that can do. I think the generative side of things, there's still a lot of confusion at the CEO or CXO level that are really setting strategy around these. So what do you see as some of the myths that have emerged here in that realm?
Well, the first, I'll list 3 myths. You asked for 3, so I'm ready. Exactly. But
we always think in threes, I think.
Yeah, I can only think. I can't hold more than 3 things in my head. unlike generative AI, which I'm sure absolutely can, but doesn't mean it's as good as you and me. So first of the three is what I just mentioned, that more human-like actually ironically means less potentially autonomous in general. The second that's interrelated closely is that I believe that there's at least an implicit belief with many people getting super duper excited that we're moving towards AGI. Now, AGI is artificial general intelligence, and the main accepted definition is that it's machines that are they're capable of doing anything a human can. So they could be the CEO of a company or anything, or the best administrative assistant you've ever had, where they're at your fingertips. Now, that general human level of capability is a huge myth, and even the idea that this incredible seemingly human-like behavior of language models is a step towards being fully human-like in that respect, I believe that's a myth. That's some people call that the first step fallacy. This is the idea that because it's better, it's, quote, smarter, that somehow, as if there's this one-dimensional spectrum of intelligence and it's moving along that spectrum, and that it will eventually reach and then surpass human intelligence. In fact, the word intelligence, and I'll put this as my third myth, the word intelligence is not pertinent to engineering, to building things, designing what computers can do, to science and technology. It's pertinent to the idea of AI, which involves the word intelligence, is a great concept for science fiction and for philosophy. But when we start using the word intelligence, and I say this as somebody who taught the graduate level courses in AI, including the course named AI at Columbia, the term AI itself automatically instills this mythology that even that the word intelligence has any particular concrete meaning that's useful or can be defined. The problem is anytime you try to define it, it sort of kills itself. It deletes itself as a possibility, because once you get a computer to do something, all of a sudden it doesn't seem so intelligent after all. So what is it that we're talking about? We're talking about it being human-like? No. Are we talking about it using certain kinds of technology like machine learning? No, that doesn't suffice. They can do really, really hard tasks? No, we can do this, that, and the other, play chess and drive cars to at least to a certain level of autonomy. So what are we talking about? We're talking about this myth that on some level, people believe that intelligence is a platonic ideal that exists independent of humans. No, intelligence is a very particular a very particular thing that humans have. It is, and you can't talk about intelligence without, as applied to anything other than a human, without anthropomorphizing it, because you're talking in human terms. So unless and that doesn't work for engineering. You can't build something without defining it. You have to define concrete quantitative metrics of how well it performs in terms of that are a way of manifesting the goal. So you define the goal to make it concrete and formal in terms of a metric. How good is it? And then you have it pursue that metric. And essentially, when you take that to its logical conclusion, that becomes supervised learning, the ability for a machine to self-improve because it has that guidance of being able to measure how good the apparatus is. Now, it doesn't need labeled data if it can simulate it, like in the case of a game or a video game. But in one way or another, it needs to have the ability for the machine during the learning process to put a number on it, to put a metric on how good it is, and then to work to improve its performance on that metric. If we're talking about the word intelligence, I don't know what that is. Any particular attempt automatically kind of removes the spirit of what people mean by the term AI. So the term AI does not help with engineering.
Right. Yeah, that's a really great point. I think the anthropomorphize machines, as soon as you start to get down that level, it just becomes sort of pseudoscience, right? Because, everybody wants to say, oh my gosh, this is the next thinking machine out there, when in fact it's very focused on doing specific tasks very well, but generally not. And I guess the other interesting one I wanted to ask you about was, sort of, I think there was one of the CEOs of one of the big generative companies out there, generative AI companies out there. He'd actually, I think it was Anthropic actually, he had mentioned that there's a 25% chance that AI will wind up destroying humanity and sort of we'll be all extinct within some period of time. What's your thought on that? Is that sort of another sort of hype cycle type of element here? I mean, do you fundamentally see a future like where that's in the realm of possibility? Especially, in the Oppenheimer movie, they talked about there being a realm of possibility back in the 1945 of igniting the atmosphere with the atomic bomb, and that was 1% or less than 1%, possibility here. It's amazing to have some people come out and say, well, there's a 25% chance that this could be a human extinction event, and that seems more sort of apocryphal. So what's your thought on that?
No, I think that doomsday stuff is what people have been calling criti-hype. So it's a way to say, hey, this stuff's dangerous, as actually a way to increase their share values because it hypes it, right? I mean, if it's so powerful that it could destroy everybody, or that it would realize that it should take over in its own self-interest and all those kinds of anthropomorphized stories and narratives, if it has that level of capability, then hey, it should really be able to help my company, right? And the least, it should be able to target my marketing better. So it's when you hype it. And I mean, now I don't mean that there are people that don't genuinely believe it. And I don't really know how to interpret the executives of these companies that are making so much, that get a lot of public attention. I don't know the degree to which they personally believe it, but I do know that a lot of people do genuinely believe it without the financial incentive of increasing their stock values. And I think it goes back to what I was saying a second ago, where there's this idea of a Platonic concept of intelligence that's just waiting to emerge, and that it'll therefore automatically be at the level of capability of a human, and then it'll be able to conduct AI research itself and self-improve, and then the Skynet's the limit, right? That's a joke, but that's all a myth. Presuppose the notion that at each step we're somehow closing in on human level capabilities, but human level capabilities haven't even been. Nobody knows what that is. I mean, the word intelligence is an allusion to human level capabilities, but the word intelligence is not defined in concrete terms. We're not measuring it. I mean, we have something we call a IQ, and it correlates together a bunch of capabilities. But again, that's not the essence of what it means. That's not what we're envisioning when we talk about AI. We're talking about a machine that you can relate to, like the machines in science fiction, that you can just sort of chat with them like you would with your buddy and all this kind of stuff. And the sense that they have this level of capability, as if that's just something you can eventually achieve independent of humanity. I think that it's a ghost story.
Yeah.
I think that it's today's Frankenstein story.
Yeah, and I think you're right. I mean, if you really do want to generate marketing buzz, fear probably is it's very marketable, right? And it's your point basically about sort of delivering value. If it's that powerful beyond human capability, certainly it should be able to impact your bottom line for your company. Which if we turn our view over to more of the enterprise, and there's been a lot of sort of discussion out there around AI first strategies, and I think before that it was mobile first, and I think before that it was really cloud first strategies. And so there's been a lot of first strategies out there. It's kind of hard to keep up. What's your view in terms of AI first strategy? Is that actually something that you talk about in your new book, AI Playbook, the AI Playbook? Is that something that you actually cover in that on that topic?
Yeah, I have. There's a page where I'm like, what? There's a problem, and I quote a bunch of people that are like, AI shouldn't come first. If you want to put AI first, no, put the business objective first, and AI, or let's call it machine learning to be specific about an actual existent technology, that comes second because it's now there to serve a business need. And that's basically the theme generally about my book. Now, my book, the AI Playbook, the subtitle is Mastering the Rare Art of Machine Learning Deployment. Rare art because, in fact, it turns out that most of these enterprise use case machine learning projects actually fail to deploy. And for example, IBM recently came out with industry research showing that the average returns are basically nil. That the average is lower than the cost of capital.
Wow.
And we did a bunch of. Participated in 2 rounds of industry research that's surveying data scientists, most recently as a part-time visiting analytics professor at the UVA school, Darden School of Business. And it turns out the story is the same from the data scientist perspective. They make models with the intention of being deployed within the auspices of a project that's meant to go to deployment, and then the models don't deploy. It's a routine project failure scenario. And there's lots of successes with machine learning deployment for sure. But on average, it's especially new initiatives that try to create new capabilities or first-time initiatives, they just fail. And the problem is that there's this lack of end-to-end practice where you start with the business objective, exactly how it's going to deploy, what operations are going to be changed in what way, by predicting what. And yes, as you mentioned earlier, when I say predict, I mean put a probability. But what else would you mean, actually, if you think about it for a second? A prediction is a probability. In fact, if you want to be sort of really strict, okay, you're not predicting unless you put your hand down and say, yes, no, definitely this person is going to buy, this person isn't, this insurance policyholder is going to have high claims, this one isn't. But that's a very trivial difference. That just means you thresholded the probability. So if the probability is higher than 90%, then I'm going to assume, yes, this is a positive case, or maybe 50%. It depends on the context and the cost of false positives and false negatives and what have you. But one way or another, yeah, you do have to draw a line if you're driving decisions. But before you do that, let's just make the probabilities and see what our options are. So it starts out with probabilities. Now, the world's not necessarily extremely comfortable with probabilities, right? So like, think about Empire Strikes Back. The C-3PO, sir, he's talking to Han Solo, the chances of navigating this asteroid field successfully are 3,280 to 1. And then our hero, who everybody loves, Han Solo, never tell me the odds, right? And then all the data scientists are like, thanks, George Lucas.
Right.
Like, come on. No, do tell me the odds. Please. Right. And so then you've got The Signal and Noise by Nate Silver. That popularizes the idea of very well of probabilistic thinking. But the thing that data scientists probably haven't quite realized, if they want to get their models deployed, is that the world is not embraced. Maybe they like the idea of probabilistic thinking, but probabilistic doing, in the sense of systematically applying probabilities to improve many large-scale operational decisions.
Right.
That's where the rubber hits the road and the pedal hits the metal and all that. That's where you're actually deploying, or as some people call it, integrating or moving into production with a predictive model that produces those probabilities. You're actually using it more than the analysis. You're actually going to deployment. So I have launched with this new book, the AI Playbook, a brand new buzzword, which is BizML, the business practice, and it's the eponymous playbook from the title of my book, the AI Playbook. It's the business practice to run a machine learning project successfully from end to end, from inception to deployment, only by way of planning that backwards. And it's across 6 steps, and you have to plan it accordingly, get the right business plan together, decide on the metrics, the performance measures that matter, which typically are not accuracy. That's almost always the wrong metric.
Right.
And then you got to prep the data, train the model, and then deploy it. And you want to get to that point. That's the culmination. You do need to monitor afterwards, but let's just even get to deployment in the first place.
Yeah, and one thing I was going to point out was that basically, I think one of the great parts, I haven't made it all the way through your book, but I have sort of made it through 75%. I think what you're talking about here is sort of the knowing doing gap, right? I mean, a lot of organizations may actually learn things from these models, but it's a whole change management effort to basically operationalize what you've learned and have the confidence to do that, right? So you have to have absolute, certainty that you're doing the right thing, and you're going to make the various changes to your business. And if you don't have that level of certainty, a lot of people are like, well, it's going to inflict a lot of change on the organization. We could be wrong here. So maybe, we're making our 10% or, or at least like covering the cost of capital here. Let's not rock the boat. And so the real question is basically the organizations that are going to be extremely successful here are the ones who are going to go boldly into this, really trust what the models tell them, and then basically have the operational capability to make those changes to deliver value to the bottom line. Because, if you know things, right, just in your own personal life, you could know that you shouldn't have that chocolate cake, or maybe, like that whole blueberry pie that you've been like working on. That's one thing, but basically like sort of having the discipline. So what your book talks about, I mean, at least from what I've actually derived, is that you're talking about a sort of a formal structure and discipline to deliver value here.
Well, you need a carrot at the end of the stick. So if our goal operationally is to resist the blueberry pie, here's how we can have our blueberry pie and eat it too. Right. Put that at the end of the stick. Say, hey, look, only after we successfully deploy can you now eat the blueberry pie. So you've got to incentivize the teams, right? The incentives aren't quite aligned yet right now, because what's happening is these failures get swept under the rug, which isn't that hard because of the AI hype. So in that sense, the degree of captured value by, as you say, operationalizing, which is another synonym for deploying it, we're kind of running on fumes, because we can do that because there's so much hype and excitement right now. But that's not sustainable. So we need to start actually getting it launched. Now, part of that isn't just being disciplined enough to be like, now we're going to take a risk. Come on, grin and bear it. You can mitigate that risk. And as a data scientist, for example, you can mitigate the risk that your stakeholder is not going to get cold feet by following this end-to-end practice, as I've outlined in the book, the AI Playbook, where the last culminating step is deployment, by planning for that step from the get-go and making sure that it's socialized and everybody understands. So perhaps even more importantly than the particular way I broke it down into 6 steps, and other people have done that, what they haven't done is given it a cool buzzword like I did, BizML, right? And what they also haven't done is cushion it in the following context, which is that it has to be deep collaboration between the data professionals, techies, and the business professionals, stakeholders, their clients, the line of business managers. Those two parties, right, the beauty and the geek, they have to collaborate very deeply across the project on all of the steps. And the business side stakeholders must learn and ramp up on some not too hard, but some semi-technical understanding of what it means to act on probabilities. Basically, what's it predict? How well? What kind of numbers are we talking about? How do you measure that? And then what do you do about it? How exactly is that probably going to transition to enterprise operation, like approve or disapprove a transaction, or whatever it is whatever operation you're trying to improve on. So the deep, specific understanding of that, not the core rocket science, not the learning from data part, but the part about what's being predicted and how we're using that and how well it predicts, a semi-technical understanding of that. So that's what I've offered with the book, is that while yes, it goes through those 6 steps and it's structured around those with 6 chapters, after chapter 0 to kick it off, because this is written by a nerd, so we start with chapter 0. But in addition to that, the book is accessible to business readers because it provides all that background, semi-technical knowledge that you need to then participate in an end-to-end successful machine learning project that actually culminates with value-driven deployment. So that's the goal. So to finish my pitch for the book, I'll say that it doesn't come out till early next year, but you can get an early copy for free of the audiobook if you pre-order on Amazon the hardcover or the ebook. So you go to the book's webpage, which is bizml.com, bizml.com, and you can see the information about getting a free immediate advanced copy of the audiobook.
Yeah, and and from what I've actually read so far, fantastic book. Very it illuminates the specific steps, but it also sort of gives you sort of the wisdom and fortitude to actually go forward and have a successful project. I mean, because, the idea is sort of collaboration breakdown, or basically, business not speaking the same language as the technologist, that actually is sort of a big problem. And that's where sort of the data science comes in as well, is that you really do need to bridge the language between the two. And then basically there does need to be the sort of this trust and, change management that actually happens with the organization. So fantastic book. I mean, a great job on that. And I can't wait to actually finish the line. I think I have 2 more chapters left. So,
it culminates with the best part.
The
payoff
course, yeah.
doesn't come until the deployment chapter. That's the big payoff.
That's the big payoff. Absolutely. So, the one other question I wanted to ask you is that, today, supervised learning, provides the majority of value in machine learning, right? And I think, Andrew Ning from Stanford, he'd actually sort of commented on that today, the value being generated from generative is quite small. It may be some productivity elements to that, like at the consumer level, but there's really not a tremendous uptick in terms of business value so far. Do you see in 3 to 5 years out that really the generative AI will eclipse sort of supervised learning, type of, predictive analytics? Or do you sort of see that as actually sort of being relative growth among the two? But obviously, because, sort of the supervised learning is so much more valuable today to the enterprise that really, generative will have a hard time catching up with it.
No, I don't, not within 3 to 5 years. I don't really see it capturing as much value as the enterprise use cases with targeting operations and driving operational decisions, which in general is supervised rather than unsupervised. And so is generative AI. It's based on supervised learning. I don't see it necessarily happening that quickly. It's pretty speculative when generative AI could ever possibly start to capture the value that it promises or that the world seems to be believing in. The difference between a general large language model that's so impressive in that it seems to be able to talk about anything and seems so human-like and to be able to kind of reason in a very human-like way. And this is sort of subjective. The subjective experience, there's no question, is awesome. I mean, it's the best demo that ever has been made ever by a computer. It's the demo of the millennium, no question about it. It's amazing. But does that mean that we can get it to actually, because right now it's having that effect because it does a really good job one word at a time. And that's what it's been trained to do. So they reached a breakthrough in that. But that doesn't mean it's been actually trained or optimized to perform well in terms of higher order goals, such as being correct. In fact, the degree to which the world's shocked when it's incorrect is the degree to which that I'm shocked that the world is shocked, because I think it's amazing it actually is correct as often as it is. So if we picked some specific domain, you're like, I just want this thing to be able to answer customer service questions for field repair agents who are fixing laundry machines and be correct at least 95% of the time and know the correct and understand the question at least 95. You put a bunch of metrics, it's a little bit hard to define because this is uncharted territory. But to get to that level of expected performance and be valuable in that way, fully autonomously, is a research project. And that's what the world's missing. It means it's uncharted and it's still TBA. Now, it could happen in 5 years. It could happen in 20 years. But until it happens in a research context where, there's reproducibility, there's concrete specifics divulged about how well it works, then it's all nothing but speculation. It's not just a matter of product development. It's a research process. So I have an old buddy. He actually started me on computer programming when we were 10. Wow. And I hung out with him recently. He works for NVIDIA now, right? And he's playing with the generative AI and making it on his laptop, just locally, drawing pictures of my face, doing things I've never done. Like, it was amazing. So we got into that debate. And I said, well, I think within a very limited domain, it's going to be able to do that. I'm going to say 6 years, but again, super speculative. And he's like 1 year. So wow. we bet $5. That's the state of the world. It all hinges on the $5.
Yeah. No, that's amazing. It is interesting though, because when you see sort of the pace that this is actually going at and the number of resources and the dollars that are actually being thrown at this, billions and billions of dollars. And, even just, even some of the, I think it was called, Micro Super, which is another company that basically is putting together these data centers and these computers that have NVIDIA chips at the center of them. Their business is exploding, and they're creating all these different supercomputers. So you wonder what is really going to be sort of the next generation of chips. Because where we're at today, the way I look at it is that it's massive computing power that we've never had before. And there's massive amounts of data. And that's actually sort of solved for today, what we're calling generative AI. The ability to do that, that seems to actually have solved and sort of amazed a lot of people. The question there is that as we get more and more data, these things are just going to improve. And as we get faster and faster computers, they'll improve. But it's almost a question of, does that hit a ceiling at a certain point? And then is it sort of algorithmically need to evolve from there in order to actually have the next level of innovation here? So it's a really good question. But I think, in terms of the enterprise, I think there's certainly tremendous value to be had from predictive analytics. And then to your point, I think on the generative side, it certainly is more of a research endeavor rather than just sort of announcing products to the market saying, hey, we've just created our new chatbot for the insurance world, or benefits, or, some other type of medical services. That has to be more research oriented. I agree 100%. But Eric, it's been an absolute pleasure. Thank you so much for doing the Unified Leadership Podcast. And I look forward to our future conversations in this regard, because I think we've only scratched the surface here.
Oh, yeah, absolutely. We need 10 more hours. Thanks for including me, Chris. I really appreciate it.
Awesome. Always a pleasure, Eric. We'll talk soon.
All right, man.
Thank you.
Now I won't